Today we're going to work once again in chi-square test. But today there will be a difference because today we're going to perform it by using calculator. As you remember, doing the whole chi-square test, it takes a lot of time. Basically to find the chi-square value to compare. Because you must develop expected minus observed to the second power divided expected per each cell and add. And it takes a lot of time. So today we are going to see how we can do that by using the calculator. Obviously, we're going to review the steps. What are the 4 steps? State hypothesis. Calculate the statistic. What will be the difference? Today we're going to do it with calculator. Then, and finally, and we compare the two values. Up to that point, clear or not? Okay. Now students will open books to page 239. Students will open book to page 239 and students will direct attention to the exercise 4. The one that we have here is the exercise 4. That exercise belongs to the set of exercises that you're working on in this thing. I would like to listen to Mrs. Ferran reading the exercise, please.
The results are given in the table below.
Okay, the table is there. The adventure, crime, romantic, science fiction, male and female. Gender, movies. Now, what it says, a chi-square test at 1% significance level. So it means a confidence of? No. What's the confidence? Tell me? But don't be ashamed. 99%. 1% of significance level means 99% of confidence. And this will be performed to decide if these two variables, if this variable and this variable are independent or not. Clear? What's the first step to perform the test? Tell me? Okay, Paula. So, what is H0 and what is H1? Raising a hand, please. Laura, H0.
The null hypothesis and the alternative.
But what is the null hypothesis? Carolina.
That the gender depends on the type of female, right?
That the variables are?
Independent.
So, gender and type of movies, it says?
Favorite.
And favorite. Genre are dependent. And what is the alternative hypothesis?
That they are not dependent. That they are not dependent.
Gender and favorite film genre are not dependent. As you have seen in previous exams, in examination, the first question is that one, state both hypotheses. Clear or not? Do you have them? May I erase? Sure? Okay. I'm gonna change the order a little bit with respect to previous explanations. And today we're going to begin with degrees of freedom. Degrees of freedom is an important concept that I need to clarify. So, before explaining again, what are degrees of freedom for this test?
The spaces you can fill without worrying about the other data.
Excellent. The spaces that you can fill randomly without taking care of the other data. So let's do it here. Vivian, could you please give me a value that I can write freely here? Any value that you obviously that makes sense. Which one? Are you 6 reading?
Yes.
Oh, sorry. 10. For the ones who didn't listen, Vivian did this. 10. So, 10, does it make sense? Yes. Less than 22? Less than 39. Today I want to do it again, but in a different order. Because in the last exercise we do it per lines, and it was too evident. Now, Andres, a value for this one.
8.
8. Does it make sense?
Yes.
Less than 20, less than 41. And up to this point, I have 2 free values. Valeria, I need a value for this cell. A value that you can put there. Not the one, not necessarily the one of the 8 values. Yes. 10. Does it make sense?
Yes.
Less than this, less than this. Can I continue?
Yes.
Stephanie, a value here. 9. Less and less than. 9. Can we continue?
No.
Unfortunately, no. Why? The value here must be found by subtracting this from this. The value here, subtracting this from this. The value here, this minus this. And the value here, this minus this. So how many values could you assign
4.
randomly, freely? 4 values. Now if you're replacing the formula,
12.
how many rows you have?
4. 2.
2 minus 1. And how many columns?
4.
So I have a problem here.
3.
Wait. So it seems I can write one more value. Where?
Should be
10.
10. The discipline is 3.
Which one?
It's 3 but before 4 degrees of freedom.
Ah. How many degrees of freedom? How many rows I have?
3.
2. And how many columns?
4.
4. 4 minus 1? 3. 2 minus 1? 1. How many degrees of freedom? 3. So how many values can I write randomly?
3.
3. So I wrote one more. Which one?
10.
Which 10? This one. In fact, yes, because once I have this one and this one, I cannot write that one. You're right. So how many degrees of freedom we have? 3. Now, to be completely precise, that's not the value we have to erase. What should be the value to erase? The last 9. What was the last value we wrote?
9.
9. Hmm? Why? Once you have that, can you find, I'm going to write with black, the ones that we calculate. Can we find this one? 7. Can we find this one? Can we find this one? Once you have this and this must be found. Yes? What will be this one and this one?
7.
Which one is 7?
Crime female.
Crime female, 7. And this one, 14. So how many blue numbers? 3. How many degrees of freedom? 3. Degrees of freedom? 3. The 3 numbers that you could write at the beginning. Up to this point, clear or not?
Yes.
Okay.
Wait.
Probably you think, teacher, but there's a formula for degrees of freedom. Why don't you just replacing the formula and that's all? More than the formula, what is important for you is the understanding of the concept of degrees of freedom. Why? When you apply the chi-square test to real-life related situations, if you apply a chi-square test with a few degrees of freedom, it will be considered too simple. Probably it's something that you can do by using regressions. So, as greater degrees of freedom in your project, more complex, it will be considered. Clear? Okay. Now we're going to continue seriously with the exercise table. Now, this one is contingency table. The one, how this table could be obtained by applying a survey, for example. Now, this one will be the one of the observed frequencies. I'm not going to show the whole process, and I don't want you to show the whole process. I want you to use the shortcut we learned in the previous class. This multiplied by this divided by this. And now, fill the table. Construct a notebook, the expected frequencies table, and in a while I'm going to take some notebooks to fill it on board. Very significant figures in your answers. Is it true?
Yes.
The first one, 11.3. Raise hand the ones who agree with the first row of the table. Is it right?
Yes.
Okay. And this is the second one.
But
Which one?
female adventure is 10.7 because the next number is...
It's a 2, you are completely right, sweetie. 10 and 7. Thank you so much, Lapita. Is it clear? So, for the ones who still don't get it, for example, this 9.75 is obtained by multiplying 39 and 20 and divide by 80. This multiplied by this divided by this produces this number. Is it clear? Do you have both tables? Clear? It is important because I'm going to close this one and go to the calculator. So I need it on your notebook. Okay, I have here one. I'm going to use. So we are going to close this. And now we will go to the calculator. Clear? There's a menu in your calculator, as usual. And you choose the first one. That is the run mode of the calculator. And we're going to record the sequences of keys that we're going to use. Clear? So, first step, your calculator, give me a second. You choose in the main menu the first one. And the first one takes you into the run mode. Clear? Now, once you are there, you are going to choose the third option, MAT from matrix with F3. Immediately you have a catalog, A, B, C, D. You may store several matrices. We are going to use A and B. And it is important for you to keep on mind which of them is A, which of them is B. So, on matrix A, we are going to store observed data. On matrix B, we are going to store expected data. Clear or not? Okay, how do you do it? You are here, matrix A, known. You press execute. And immediately there's a frame asking for dimension M and N. M are rows, N are columns. Clear? How many rows do we have? 4 rows.
No,
Two rows and 4 columns in this case. And we have it. 2 rows. Remember, rows, columns. Row and column. 2 rows, 4 columns. So the first one will be observed data. What is observed data? The one that you have on book. So it is 15, 12, 15, 12, 2, and 12. If I'm right. And 7, 9, 18, and 6. And 5. 7, 9, 18, and 5. Clear? Okay, that's the first one. Now, I press exit. And I go back again to the menu. Now, I scroll down 2 matrix B. Dimension, once again, 2 rows and 4 columns. Execute. And here I need the expected value that you found previously. So do it quickly in the calculator so I can take your notebook. Or you have it here. Excellent. So it says 11.3, 10.8, 10.3, 8.71, 10.7, 10.2, 9.75, and finally 8.29. Up to this point, clear or not? So, first step, I input, observe, and expect. Now, I must go to the statistics menu. So, exit, menu, to statistics. There's no list because we didn't have information in list to be processed. We need the information that we stored in the previous matrix. So now, graph test F3. In test G. And there are two options, degrees of freedom or two-way. We are going to choose two-way. And it says, observed, A, expected, B. Now, teacher, what happens if I have a lot of matrices stored and my information is not there? You can use this one to change it. Yes, I can press here. If I don't have it in that one, I just put the other one. And you scroll down up to execute. We are going to calc at first. So, what is the chi-squared value?
18.9.
I'm going to write it complete. It's not necessary, but I'm going to. And the p-value. The p-value is too few. It's a few because it's this number. This number is in scientific notation. What I have there is 275, 77 times 10 to the negative 4th power. What that means?
There are 4 zeros.
There are 4 zeros in here at left. So it's a very, very small number. And degrees of freedom? 3. Up to this point, clear? Okay. Now we are going to remember how to analyze it. But before, there's something that we need. What was the significant level that was given?
1%.
Okay. 1%. And degrees of freedom? 3. So I will go to the last slide. That's what we need. So, level of significance 1%. Degrees of freedom 3. What's the critical value? So, critical value remember what I told you, there's a table. Even if it is not given in examination, there's a table in which you can find degrees of freedom and significance level to determine critical values. And now we're going to compare. Now we can compare. What was the calculated value? 1898. What is the critical value? 1134. So what do I conclude? We reject the null hypothesis. The chi-square calculator is more than the critical value. This is greater than this. So we reject the null hypothesis. As I have rejected my null hypothesis, what is left? If I reject the null, what is left? The alternative hypothesis. What alternative hypothesis says? That they are not dependent. That they are independent. Remember that it is not like that. They are not dependent. Clear or not? Before you leave, there's something else that I want to show. It will take a second. I'm going to run the test again, but now I'm going to draw. And I'm going to show the chi-square value. Do you see a shaded area? The chi-square value is far, far away. When that happens, the test suggests to reject. As homework, I will ask you to run some chi-square from that exercise 5A. The test but graph and verify in the graph the shaded area that appears when the test says accept, when the test says reject. Thank you so much, class dismissed.